Hello everyone. So this is a video for section 8.1 Law of Sines for the Pre-Calculus course. Here is a question. Find all possible triangles having angle B 26 degrees, side B 9 and side C equals 12. So let us first draw the figure to get an idea of what is given to us. So triangle ABC, angle B 26 degrees. Side opposite to that is little b, which is 9. And side opposite to angle C is little c, which is 12. Now here we are given side angle. So we are in an SSA situation. And if you recall, SSA is not a congruence rule for triangles, which means you can have multiple triangles having these measurements. So let's try to find all those possible triangles. Now, first thing we want to do is let's state what the law of sines looks like. So law of sines, sine of angle A by little a equals sine of angle B by little b equals sine of angle C by the side opposite to it. Why are we using this law? It's because we have to find all the missing measurements for this triangle, and this law precisely covers all those missing measurements. And the advantage here is, if you can see, we are given angle B and side B, which means this middle fraction is completely given to us. So using this fraction and setting the others equal to it, you can solve for the missing pieces. So first, since we are given little c, we want to start by using this piece. So sine angle B by little b equals sine angle C by little c. And this ends up being sine of 26 degrees by 9 equals sine of angle C by 12. So let's see what we get. Now plug this into a calculator, make sure it's in degree mode and not radians, and then we end up getting from here, for angle C, you're going to have arc sine of 0.589, and this is approximately equal to 35.7 degrees. So we got this as 35.7 degrees. Now, next thing we do is we have to find the remaining. Now for that, we can find angle A using angle sum property of triangles. So angle A is going to be 180 degree minus angle B plus angle C. And this ends up being 180 degrees minus angle B, which is 26, and angle C, 35.7. And thus we get, this is also an approximation because we rounded off angle C. So this is 118.3 degrees. And lastly, since we found out angle A, now you can use the middle piece to find side A. So using that, using the fact that sine of angle A by little a equals sine of angle B by little b, we get this is going to be equal to sine 26 degrees by little b, which was 9. And then solving everything, you end up getting that side A is going to be approximately 18 units. And thus, we have got one set of solutions here, which consists of angle A, angle B, angle C. Let's make the table here. And angle A we found out was 118.3 degrees. Angle B given to us is 26 degrees. Angle C we found out 35.7 degrees. Side A is 18, side B 9, and side C 12. That's one possible triangle. Let's check if there is another triangle also here. So this is the first possible triangle. Now here, the first thing we solved was for angle C, and we found out that to be 35.7 degrees. How do we look if there is another possible triangle? Here is what we do. Try to find the supplementary angle to this angle. Supplementary angle means 180 degree minus this value, 35.7 degrees. And this is going to be 144.3 degrees. Now, consider the supplementary angle to this as your angle C for the next possible triangle. Now, if this is your angle C, to check if it's possible to have another triangle, let's add the given angle, which was 26 degrees, to this angle, 144.3 degrees. And what we end up getting is going to be 170.3 degrees. This measurement, as you note, is less than 180. If it's less than 180, you can have another angle A to add to this so that the total becomes 180, and so a triangle is possible. And that angle A is going to be 180 minus angle C plus angle B. So that's 180 minus 170.3, and this ends up being 9.7 degrees. So we have a new triangle having these measurements for angle A, angle B, and angle C. Now again, using the law of sines, find the remaining measurements. So the same work follows. So we would have just filling in whatever we found out. So sine of angle A by A. So sine of 9.7 degrees by little a is equal to sine of angle B, which is 26 degrees, by little b, which is 9, equals sine of angle C, which is 144.3 degrees, by little c, which is 12 units. Now, using these two pieces, we can find little a, and that is going to be approximately 3.5, and that's it. That gives us all the measurements. So let's list out the measurements for the second triangle here using different colors. So we have angle A, which was 9.7, angle B 26 degrees, angle C 144.3 degrees. Little a is going to be 3.5, little b is going to be 9, and c is 12 given to us. So these are the two possible triangles having measurements for angle B 26 degrees, side B 9, and side C 12. Thank you.